Absolute value equations and inequalities. In this lesson, you'll be able to write and solve absolute value equations and inequalities. So the steps to solving an absolute value equation is you want to get the absolute value on a side by itself. Second, you're going to check to see if there is a solution. If the absolute value is equal to a negative number, then there is no solution. You're then going to drop the absolute value bars and rewrite each equation, setting 1 equal to a positive number, 1 equal to a negative number. Solve both equations and check that the answer makes a true statement. So in this example, I'm going to follow the steps. I need to isolate my absolute value first. So to isolate the absolute value, I need to get rid of 2 that's being added. So I'm going to subtract 2 on both sides. 2 is going to cancel, and 5 is going to equal the absolute value of x. So I'm done with my first step. I've already isolated my absolute value. My next step is to set my solution 1 equal to a positive number, or we'll have 1 equal to a negative number. The reason being is because when x is inside of these bars, we don't know if x is positive or negative. All we know is when it simplifies, we end up with a positive number. So that's why you need both solutions for x. In this problem, the absolute value is already isolated. So what I'm going to do is I'm going to take my 2x minus 3, set up my 2 different solutions, set it equal to positive 1, or 2x minus 3 is equal to negative 1, because again, in these bars, we don't know if our x is positive or negative. So then we solve, adding 3 to both sides of the equation. 2x will equal 4, divide 2, and x will equal positive 2. Here we're going to add 3 to both sides of the equation. 2x will equal 2. Then we'll divide 2 on both sides, and x will equal positive 1. So we have our 2 solutions. Go ahead and pause the video and see if you can do this one on your own, and then unpause to check your solution. All right, so we need to get this absolute value isolated. What is preventing absolute value from being isolated? Well, there's 3 that's being multiplied and there's 8 that's being added. So the first thing I'm going to do is I'm going to get rid of the 8 that's being added, because we undo our addition or subtraction first. 8 is going to cancel. I have 3 times the absolute value of x plus 6 equal to negative 3. Lastly, to get the absolute value by itself, I need to divide 3 on both sides. So the absolute value of x plus 6 is going to equal negative 1. Now, because the absolute value is equal to a negative number, there's no solution for this equation. Go ahead and pause the video and see if you can do these 3 on your own, and then unpause to check your solution. All right, so the first question, I'm going to add 2 to both sides of the equation. I end up with 8 is equal to the absolute value of x, and then I'll go ahead and set up my 2 different solutions. So I have one solution at x equal to positive 8, or another solution at x equal to negative 8. Second question, to isolate the absolute value, we'll have to divide 2 on both sides. 2 cancels. absolute value of x plus 5 is going to equal positive 2. So we'll separate, have our two different solutions. So we'll have one at x plus 5 equal to positive 2, and the other at x plus 5 equal to negative 2. We'll then solve each, subtracting 5 on both sides. We end up with negative 3 as one of our solutions. Or when we subtract 5 here, we end up with x equal to negative 7 as our other solution. Last but not least, we're going to do the same. Here, our absolute value is already isolated, so we can start this by setting up our two different solutions. X minus 6 is equal to positive 12, or 3x minus 6 is equal to negative 12. We're then going to solve each, adding 6 to both sides. 6 cancels. 3x is going to equal 18. And then we'll divide 3 on both sides for an x equal to positive 6. Here, when we add 6 to both sides, we end up with 3x is equal to negative 6. Then when we divide 3 on both sides, we end up with an x equal to negative 2. Next is absolute value inequalities. KISS stands for keep it, switch, switch, which is what you're going to be doing with these different inequalities. So step 1, we're still isolating the absolute value expression, just depending on what side of the equation the inequality, that is on. Step 2, you're going to write the problem in two different cases. You're going to keep it the same, just drop the bars for one. The second is very important because you'll need to switch the inequality symbol and the sign of the number on the other side of the inequality symbol, which you'll learn when I actually get to the problems. Never mess with stuff that's on the inside of the absolute value bars. You're then going to solve both inequalities and graph your solutions on a number line. So to start, these two, we have x is less than 3. So one solution is x is less than 3. Our other solution is x. We have to flip the inequality and change the sign of our solution. So we have to do both of those, and then we're going to graph. So negative 3, positive 3, we have an open circle. So our values of x are greater than negative 3, and our greater than values go to the right. However, our values of x are less than positive 3, so open circle going back to the left. So it looks like these two will meet in the middle. Our solution will meet in the middle. All of our solutions are in the middle. Next, we have x is greater than 3 to start. Our other solution is x is less than negative 3. So now let's see what happens. So our smaller value goes first on our number line, which is negative 3, with an open circle. Our values of x are less than negative 3, so they're going to be going to the left. And at positive 3, our values of x are greater, going to the right. So here we have shading, and here we have shading. So notice, when we start with greater, you think great or, It's an or problem. If you notice when we start with our less, you think less and we have an and graph here and an or graph here. So if when in doubt, just graph what you see. Last but not least, I am going to solve each absolute value inequality. So starting with my first inequality here, it's already isolated. So no need for me to isolate my absolute value. I am going to start by setting up my two solutions. And this is starting as a great or. So this should be an or graph when we finish graphing. So we have 3x minus 6 is greater than or equal to 9, or 3x minus 6 is less than or equal to negative 9. Remembering that we had to flip the inequality and change the sign. So here we're going to add 6 to both sides of the inequality. 3x is going to be greater than or equal to 15. We're then going to divide both sides by 3, and x will be greater than or equal to positive 5. Versus here, when we add 6 to both sides, we end up with 3x is less than or equal to negative 3. And then we're going to divide 3 on both sides, and x is going to be less than or equal to negative 1. We're then going to create our graph here on the number line. So at negative 1, we have a closed circle, and our values of x are less than or equal, making them go to the left. Versus at positive 5, we also have a closed circle. However, our values of x are greater, going to the right. So we're shaded, going in opposite directions. For the next problem, we have a less and, so we should end up being shaded in the middle for our graph. So we have 4x minus 12 less than or equal to 20, and 4x minus 12 greater than or equal to, don't forget to change the sign and flip the inequality, negative 20. We're going to add 12 first. 4x will be less than or equal to 32. We'll then divide 4 on both sides, and x is less than or equal to 8. Here we're going to add 12. 4x will be greater than or equal to negative 8, and then I am going to divide 4 on both sides. So x is greater than or equal to negative 2. So on my number line, smaller number goes to your left, larger number to the right. My values of x are greater than or equal to negative 2. So I'm going to have a closed circle. And the values that are greater than go this way. Versus at 8, I have a closed circle. But this time my values are less than or equal to, making them go to the left. And they'll end up shaded in the middle.